So we ended last tape talking about some philosophical issues of mind and body and general background, as well as some of the techniques that they use in neuroscience. Chapter 2 in your book kind of starts talking about neuroanatomy. Neuroanatomy, the science, if you will, of looking at structures of the brain, but actually the field is a little more than that. It actually goes back to phrenology. Remember what the idea of phrenology was? What is the structure and what does it control by looking at bumps on the head? Neuroanatomists actually are not just interested in what structures are in the brain. They want to know what the structures are, how they connected, and how these structures are related to mental states. Of course, anatomy is body, right? So in the mind-body thing, the idea is, well, when somebody's thinking about something, perceiving something, sensing something, which are all perceptual states, mind states, how does that link to structures in the brain? We can many times study these areas and these structures by seeing what happens when they're not working correctly, and then that tells us a lot about what they do. So the thing I've done on your outline is I've included a link that has a picture of functional neuroanatomy. So we're going to talk about the different parts of the brain, what they do, how they work, and hopefully this will be at least mildly amusing to you. This part might be more outline format because it's like, what is it, where is it, and how does it work? The brain is very generally divided into 3 general areas. Are you having a good time yet with this? We have the hindbrain, we have the midbrain, and we have the forebrain. So I'm going to start with the hindbrain for you here. There's nothing like lecturing on stuff I already know. The hindbrain. There are a number of different structures in the hindbrain. Good thing you don't have to memorize this, huh? In the hindbrain, we have the cerebellum. The cerebellum, the main, it's in the hindbrain, the very back of the brain, if you look here. Its function is to really control motoric functioning. Movement, balance is all based on the cerebellum, the singly largest structure in the brain. Because movement and balance is certainly way up there on the scale for human beings. We can have fine motor movements, we can have walking movements, our hand movements can happen. There are a lot of different movements that occur in our body, and the cerebellum is in charge of that. When you drink too much alcohol, there's a lot of receptors for alcohol. Guess where? In the cerebellum. And then you can't walk straight. Okay, so we got the cerebellum. Second structure, the pons. The pons is kind of the sleep and arousal area of the brain. It's once again in the hindbrain, basic fundamental functioning. So motoric functioning in the hindbrain, sleep and arousal are controlled in the hindbrain, and finally, last but not least, the medulla, or as my wife likes to say, the medulla oblongata, because it's kind of oblong. The medulla is kind of, how shall I put it, the Snow White and the 7 Dwarves area of the brain, if you will. You know, when you're teaching this for 20 years, you have to come up with mildly amusing things to cover here. Why do I call it the Snow White area? This is where basic biological reflexes are located. So the medulla controls things like the gag reflex, like throwing up, coughing, sneezing. There it is. Well, there was no 7 dwarf named coughing, was there? But there was sneezy. So basic biological functionings, blood pressure, heart rate, these are all controlled, and breathing are controlled by the medulla. So the medulla really helps the brain stay in balance here and provides these basic reflexes as well as heart rate and blood pressure and breathing. So that's the hindbrain. Feels like an exciting game here, doesn't it? Next, we'll go for 3 structures in the midbrain, and there's a lot more structures in the brain than these, but, you know, this is an ADP class, so why should we have to cover that much? Okay, so 3 structures in the midbrain. We have the substantia nigra, as well as the superior and inferior colliculus. What a fun word that is to say, huh? Substantia nigra, do you know how that translates? That's dark black substance. The substantia nigra in the midbrain, which is kind of in the middle. Oh, and I forgot one other structure as well that I have to say here. It's in your outline, though. I want you to include it. We'll get to that later. The substantia nigra is basically one of the areas that gets destroyed when you have Parkinson's disease. It's also very involved, obviously, in motor behavior. There's a lot of dopamine in the substantia nigra, and it's very involved in motor behavior and Parkinson's disease. The superior colliculus. It's superior because it's a lot better than the inferior colliculus. Do you believe in any of this? Hopefully not. The superior colliculus is basically in charge of eye movements, if you will. It works a lot with eye movements. The inferior colliculus works a lot right now with processing acoustic information, sound information. And last but not least, the periaqueductal gray, which you can see on the lecture 4 of the handout, the PAG. The PAG has a lot of the brain's opioid receptors, or opiate receptors. So pain and pleasure are located in the periaqueductal gray. The reason it's called this is because there is a cerebral aqueduct up in your brain, cerebral fluid, and the periaqueductal gray is right near there, near the aqueducts. So, are we still having fun here? I thought not. That's okay, we got a couple more structures to go. That's why I'm getting paid all the big bucks here. The forebrain. The forebrain's connected to the hindbrain. The hindbrain, well, we better stop singing. Okay, so the forebrain here. The forebrain has two major areas. The major lobes that we have, as well as the subcortical region, which is right below the lobes. Let's see if your little handout has this. Kind of-ish, but not quite. Yeah. Looks like the lobes are kind of in the limbic system kind of area here, as well as the thalamus. So let's give you a few structures in the subcortical region. That's right below the cerebral cortex. We have quite a few interesting structures here. We have the hippocampus. The hippocampus, what does that control? Well, if you can actually bring up a picture of the hippocampus, when a neuroanatomist looked at this structure in the brain, remember these guys just stare at slides all day, to him it looked like a seahorse. That's what hippocampus actually means. If you can't remember something during the day, or if you ever take a test in a psychology class and you can't remember something, instead of writing, I can't remember this, write, I'm sorry, Dr. X, my hippocampus wasn't working well today. Hippocampus works a lot for memory. So the hippocampus is for memory. The amygdala. The amygdala is with rage and emotion. So negative emotions are housed in the amygdala. Aggression, nasty emotions and so forth, they're housed in the amygdala, which it looks like you can see on page 2 there. So we got the amygdala. We've got the hypothalamus, which is right below the thalamus. The hypothalamus, as you know, controls the whole endocrine system. So it works with other parts of the brain to control hormones in the body and regulate the body in terms of sleep, eating, sexuality, temperature, drinking behavior, eating behavior. All of these things are controlled by the hypothalamus and the pituitary gland, which is also in the subcortical region. Last but not least, we have the thalamus. The thalamus is considered the relay station of the brain. When any information comes up to your brain, the first structure that it hits from your senses is the thalamus, and the thalamus will send it out to different regions of your brain. Are we still having a fun time with this? Okay, last but not least, we have the lobes. Woohoo! Don't worry, life will get a little more exciting than this, although you may be interested in this. We have 4 lobes, okay? We have the parietal, the occipital, the temporal, and the frontal. Or the way I memorized it in 1982 in my neuroscience book was POT F. But you don't have to memorize things here. Parietal. The parietal lobe is concerned with basically attentional processes. And very interesting in the parietal lobe are all the areas of sensory, all the areas of your body that sense things. I'm trying to see if there's any picture in the book in regards to this. The parietal lobe. Let's see what we got here. The book kind of gets into it. It looks like page 56, 57. So many pictures, so little time. Turn to page 65. All the areas of touch are in the parietal lobe. When somebody touches you on the skin, let's say your eyes are closed and somebody touches you, they're in an area, it looks like on page 65, it's called the somatosensory cortex. All the areas of touch of your body, those areas that are very sensitive, your face and your hands, have more areas of touch, and that is your somatosensory cortex. All the areas of touch are then actually linked to all the areas of motoric function. So if somebody pokes you on the arm or smacks you on the wrist, could you hear that? You might move your wrist because the motor areas are right over on the frontal lobe. So your parietal lobe has all the areas of touch for your body. The occipital lobe, vision. The occipital lobe has vision as well as a very higher order visual. No, I'm not saying that right. Your occipital lobe has vision. If somebody gets clocked at the back of the head or has some head trauma, they might lose their ability to see. The temporal lobe. The temporal lobe is most responsible for hearing and sound perception. And actually there's some areas in the temporal lobe that are actually advanced processing for complex visual things like faces. And finally, the frontal lobe. The frontal lobe is perhaps the most interesting. Higher level cognitive functioning there. Thinking, planning, integrating the senses are in the frontal lobe. In the very back of the frontal lobe is once again the motor cortex, which controls all areas of movement in the body. So if somebody actually gets a trauma to the brain and they can't speak anymore, that's a motor problem. It's called Broca's aphasia. And if somebody has Broca's aphasia, they probably have some lesions in the motor cortex if you look on page 65. So, now that I've baffled you with well, I can't say that last part of that word. If you look on page 66, it was a very sad time. They used to do these prefrontal lobotomies on people. And if your frontal lobotomy isn't there, then you really can't do anything very advanced, and they show the picture on 66. So these brain areas, these neuroanatomical areas, control a lot of functions of the body. The purpose of this presentation was just to share some of these structures and functions with you. Type out for this one, it probably is a detailed outline. If you see anything else in your book that you want to know about, you can write that as well, but those are the structures of the brain. Thank you very much.